Hello everyone, Mr. Fawcett back here with part 2 of our intermediate value theorem lesson, and this video is strictly going to be going over some practice problems using the intermediate value theorem. So we're going to go to the 5th page of these notes, I believe, and as always I would continue to ask you to pause the video, try these practice problems on your own, and then come back to the video and compare your work to mine. That's how you're going to get the most out of this content. So for the problems below, determine whether the IVT is applicable. State why or why not. And in parentheses, I give you a hint, think about the initial conditions. If the theorem is applicable, find the value of C guaranteed to exist by the theorem. You can put a period there. Okay, so for number 1, let's check the initial conditions. We are asked to see if there is a C on the interval -4 to 1, the open interval that is, such that f of C is equal to 2/3. So that means the function must be continuous on the closed interval -4 to 1. Now, the only place this function is going to be discontinuous is at x equals 2, right? Because that's when our denominator is equal to 0. So 2 is not on this interval, so the function is continuous. So f of x is continuous on the closed interval -4 to 1. You do need to write that down. We are also going to have to state that the second initial condition is true or false. Second initial condition says that the L value, or the f of C value that we're looking for, in this case 2/3, has to be between the two y values of our endpoints. So we need to check f of -4, and if we substitute that into the function, we're going to get -1 over -6, so that's going to be 1/6. We need to check f of 1, because that's the other endpoint. So that's going to give us 4 over -1, which is equal to -4. So does 2/3 fit between -4 and 1/6? And it doesn't, right? 2/3 is outside of that interval. So 2/3 is not between 1/6 and -4, thus IVT is not applicable. And we don't even have to try to find that C value if we are unable to use the IVT. Okay, let's look at number 2. Again, we are going to start off with trying to show that the initial conditions work. So this time the interval is -1 to 3. And we already said that this function is not continuous at 2 because there is going to be a vertical asymptote. The denominator is equal to 0. So 2 is on the closed interval -1 to 3. So right off the bat, f of x is not continuous on the closed interval -1 to 3. You can put in parentheses vertical asymptote at x equals 2. Thus, IVT is not applicable. And again, we don't have to go any further. If it fails one of the initial conditions, it doesn't matter whether it passes or fails the other one. We can't use the theorem. One thing I will say is that if you're not sure what type of discontinuity it has, but you know it's not continuous, don't take a guess. Don't say it has a vertical asymptote. Don't say it has a jump discontinuity. Don't say it has a removable discontinuity or a point discontinuity. Just say that it's not continuous at that x value, and that it's not continuous over the interval. Okay, let's look at number 3. Maybe we'll be able to use the IVT here. Make this a little bigger. Okay, so we have a function, p of x. It's an exponential function, e to the power of x plus 2. We are looking at the interval -2 to 1, closed interval, and we're looking for a y value of 5. So let's first think about, is this function continuous on the closed interval? It's an exponential function, and the base is not 0, so we don't run into that 0 to the power of 0 problem. Otherwise, exponential functions are always continuous. So in this case, it's p of x, not f of x. So p of x is continuous on -2 to 1 closed interval. Now we need to check the y values of the two endpoints. So p of -2 is equal to e to the 0 power, which is equal to 1. P of 1 is equal to e cubed. We don't need to know what that is, right? E is around 2.7, so it's around 2.7 cubed. 2.7 cubed, though, is going to be greater than 5. So 5 is between p of -2 and p of 1. Again, you don't have to state what the specific value of e cubed is. You can if you have a calculator, but if you don't, you can just leave it as e cubed. That being said, it may help you to understand what that is, so maybe you want to go ahead and punch it in the calculator now. And if you do, you'd realize that it's approximately 20.085 truncated. So not the discussion for now, but you can either truncate your decimals to 3 places or you can round to 3 places on the AP Calculus exam. And that's the rules we'll follow in this class. Okay, so because these two initial conditions hold true, right, you can say, thus IVT is applicable. And you do need to state both the initial conditions, show your work to show that they hold up, and then say that you're able to use the IVT. Once you do that, you can then focus on finding that C value, right? So we need to find out where the function is equal to 5 and find the C value on the open interval -2 to 1. So we just need to figure out, we need to set E, and we're going to call it C. So we'll just say C plus 2 is equal to 5. We can use properties of exponentials and logarithms to solve this, to get to simplify base E. So if we do natural log of both sides, these simplify. We're left with C plus 2 is equal to the natural log of 5, and we get C is equal to natural log of 5 minus 2. So this is not clear at all what this number is. So we are going to punch that into our calculator. I'm not going to bring up my software just because then I'd have to erase all of this work we have. So you can just punch this in on your calculator on your own and see that it's approximately equal to -0.390 if we truncate the decimal. We do need to check to make sure that this is in between. I mean, we know it's going to be on that open interval, but a way to check to see if we did it correctly would be to see if it's on the open interval -2 to 1, right? If we get something that's not on that interval, maybe we get something that's outside, it doesn't mean that the IVT was wrong. It means that we may have done our algebra wrong, right? If our initial conditions are true, there has to be a C value that works, so we may have just solved the equation incorrectly. So it's just a good way to check. All right, let's move on to the last page. We're about 10 minutes in here. number 4 gives us a function f of x, and our interval is from 3 to 5, and we're looking for an L value or an f of c value of -4. So first thing to check is to see if the function is continuous over that closed interval. Just to be clear, that -2 is part of the function. And again, we have a function that is mostly exponential with a constant on the end. And the base is not 0. So again, if it's a real number base, these functions are always going to be continuous. So f of x is continuous on the closed interval, 3 to 5. Let's check to make sure that that y value, or that L value, which is a y value, it's also an f of c value. It just kind of depends how you're thinking of it based on the theorem we wrote down. We need to make sure that's in between f of 3 and f of 5. So f of 3 is equal to -1/2 to the power of 0 minus 2, which is equal to anything to the power of 0 other than 0 is 1. So we get -3. Make sure you're applying that exponent of 0 first and then multiplying by 1, because that negative is outside of the parentheses. Okay, let's look at f of 5. So we get 1/2 to the power of -2 minus 2. Thinking about your rules of exponents, so this really becomes, we take the reciprocal, so 2 over 1, and make the exponent positive. So this becomes -4. Okay, 2 squared times -1, -4. So -4 minus 2 gives us -6. So we can say, yes, -4 is between f of 3 and f of 5. And thus, IVT is applicable, right? But you have to show that the two initial conditions are met before you say that. Now let's find the actual value for where the function equals -4. So we have, and this may be, the algebra is going to be a little bit tougher than the other problems. I'm going to put c in place of my x. You can keep it as an x and just change it to c at the end. I'm going to add 2 to both sides first. I'm going to multiply by -1 or divide by -1, however you want to think about it. And then, so we're going to apply log base 1/2 to both sides. Solution is going to look a little funny, but the math holds up. The two bases here simplify. So I'm left with -c plus 3 is equal to log base 1/2 of 2. Then I am going to subtract 3 from both sides. And divide both sides by -1, which gives me 3 minus log base 1/2 of 2. And again, you can check to make sure that that number is on the interval, the closed interval 3 to 5. And if you punch that into a calculator, you would get c is equal to 4. Nice, it comes out as a whole number, no rounding needed. Okay, we're going to stop the video there. I know there's 2 more practice problems. I would encourage you to try those on your own. If you have any questions, feel free to get back to me and I can help you answer them. Other than that, enjoy the rest of your day.